In this lesson, we will talk about solid principles in Laravel, or in PHP actually. And solid is a set of 5 principles which are just for maintainability of the code, to make it more readable, extensible, and kind of switching the code into layers, splitting the code into layers, which are easier to maintain. And principle number 1 stands for letter S, is single responsibility principle. So that's the topic of this video. And I have an example which is the most typical for me in real life. It's too much logic in controllers. The principle, single responsibility principle, well, it's called single responsibility. I'm not sure how to explain that in other words. So every class has to have single responsibility, so responsible for one job, for one function, for someone working with one entity and doing something with that. If it touches multiple entities or multiple topics, then it should be extracted to separate classes and then called from there. And typical example, as I told you, is controllers. Quite a lot of times people put everything in controller, all the logic in, for example, store method. I have kind of a fictional example. I won't even run that code, but look what we have here. In store method, in resourceful Laravel controller, we have validation for user permission, validation for fields. Then we're gathering the data into array and then doing some manipulation with that array. So some condition, some field has been changed. We set author ID by default from the session for multi-tenancy. We specify special chars. Then we create that record for that page. So that's data manipulation. No, that one. So data manipulation layer, then data saving sentence, and after that also we have to upload the photos for that record. So don't you think it's quite a huge amount of logic in a controller? And now let's step back a little and think, what is a controller and why is it called a controller, the word itself? So imagine, in my eyes, I imagine controller as a person. So imagine a factory, for example, with a lot of workers, and controller is a shift manager who wants to accept the job. So accept the input, the parts for the factory, the pieces, and then he defines the job for the workers, and then gives the input for the workers. Workers do their job, assembly line, for example, they assemble iPhone, for example, and then manager's job is to accept that result iPhone and then present that to consumer, to seller, to shop, to wherever. So in my opinion, controller's job is not to do the work, any of the work. He doesn't even know how the work can be done. He just knows the input, the parameters, and the output, and that's it. So in this case, controller should know about the request. So we have some request there. Then we need to validate it. So that's step number 1. We need to do some manipulation with it. Then we need to save it. And then we need to upload the files. And controller shouldn't even know about all of that. What it should know is, first of all, validation is a separate layer. I already have that actually created in requests. So form requests files that we already discussed previously in this course. So you have 2 functions, authorized and then rules. So by using this separate class, you can delete those 2 altogether. Then this part probably should be somewhere else, like it's a matter of preference whether you store everything here as a job or separate it. So logical would be call a job, for example, job page saving job dispatch something, and the parameter would be request. Again, I won't run this code and the job doesn't exist, but in the job would take care of all of that. actually page would be the result of that, and then this would be inside of the job, actually not even that. So everything would be inside of the job, and that's it. We don't even need that. In this case, we don't even need the page variable, but in other cases you may specify page as a result and then redirect with, for example, with message page title was created, something like that. So that would be the single responsibility principle without violations, because controllers' single responsibility is to, well, not exactly one responsibility technically. Technically, there are a few. So accept the request, pass it to workers, collect the result, and pass it to wherever, to view, to redirect, to JSON API return something, so return it. And that's it. And all the logic should be inside of somewhere else, inside of one job. It could be a service, it could be repository. We will talk about that later in the course. But the single responsibility principle talks about one single responsibility for every class. And I hope with this example you will understand the principle number 1, and we can move further to principle number 2. In this lesson, we're moving along our solid principles lesson series, and the more I think about it, the more it is difficult to understand and to come up with real-life examples, specifically in Laravel, because solid principles are talking more about object-oriented programming, design, interfaces, and all of that, which is not that often in Laravel. But I'm trying to come up with real examples, and today we're talking about letter O in solid. So first S was single responsibility principle, second O is open closed principle. And in theory it sounds like really not really clear. So any entity should be open for modification but closed for change. So open for extension and closed for modification. What does it actually mean? This is the example. So for example, you have salary dashboard of a list of employees, and you have a calculator of total salary of them. So we have 2 workers here, 2 employees, and this is how it looks. So we have a controller, we have a model employee, and every employee has hours worked and hourly rate, which is the same for everyone, which is public property of Eloquent model. And then you have a salary calculator kind of service, you can call it a class, which calculates total salary. How does it work? It just goes for each employee and has a formula of hours worked times hourly rate and returns total salary, which is viewed here. Everything is fine so far and everything is good, but I'll show it, no, not salaries, which is the index. Salaries index, nothing too fancy here for each employees and total salary. Now all those design principles and all those solid talk about the cases that something needs to be changed. For example, some new requirement comes up and then you have to modify the classes in really inconvenient way. So the principles are talking about the fact that you need to think upfront what may change. What should be abstracted, what should become an interface maybe, what should become the rule, so you wouldn't have trouble modifying them in the future. So in this specific case, let's say, so we have employees and we have their formula, which is inside of that calculator. Now what if the requirement changes and we need directors, not only employees but directors, and also calculating their salaries, but with a different formula. So that's the main thing. I have that example almost, so we will live code it here, kind of. I have another Eloquent model called director, and the formula is totally different, including the fields. So the field is not, that's why it's a separate Eloquent model, that is not employee. So directors don't have hourly rates and don't have working hours. They have start date. Let's imagine that's a fictional formula, but still, they have start date, and their actually monthly salary depend on start date, and percentage of how many months they worked in this company. So the more they work, the more they receive the salary, which is quite often in business world. And now, what if we want to calculate director's salary, right? We copy and paste here. So director all, and then we use the same calculator for director's salary, and we specify those here. So directors list and director's salary. We pass them into the view, and we also, come on, PHP Storm, don't give up on me. Yeah, so we also view employees along with directors. So another div, copy paste, employees, directors, name, hours worked are irrelevant. So start date is relevant. And this should be directors, ASCII director name, and director start date. Let's put it in format this, that one. And total salary is director's salary. Okay, and we will somehow put that into that calculator. So we're using the same function, calculate total salaries of directors. Actually, this is wrong. Now, how do we get that formula into here? Because it's a different formula and different fields. So this is where we violate that open-closed principle, because this function, this class, this library, this calculator should be closed for modifications, but open for extension, which means we shouldn't ever, well, not ever, but to the minimum, we need to make minimum changes for that class if some requirements change. I know it sounds confusing, but let's stick with example. So to calculate the salary, we will need to have if employee instance of class employee, then we have this formula. Else if employee instance of director, then we have another formula which will be, I have that in my Sublime prepared. It's pretty complicated. So fixed month, so employee fixed month, which is the property of this director eloquent model. Then start date is employee start date, different months, and monthly percentage is also employee property. Okay, and we change that to this. Okay, and we're good. So no big deal, you would think. If it's employee, then it's one formula. If it's director, it's another formula. But what if we have another layer, like third layer, third type of employee, I don't know, like shareholder, for example, or something like that? It's really bad design to have instance of in general. Like if you have to do instance of and check the class, that is a sign of a bad design, bad architecture. So we see how bad it is. Now, how can we change it and how to make it better? To help with that, we will introduce interfaces. Well, one interface. We will set up a rule that every class that is defining employee in whatever form should have a function calculate salary. And we did exactly that. I already had done it. So we have an interface with only one public method. So nothing is complicated, only one method, and that's totally fine. And we will specify that every class, both employee and director, should implement that interface. Implements salary interface. And it appears here. And then we must specify the method called calculate salary. Calculate salary. And here inside of the actual method, inside of the actual class, we can do whatever we want. We have whatever properties of that class we may need, which means that we can copy here, copy and paste it into here. Total salary equals this. Then it becomes this, so we don't need to have employee. Actually, we don't even need that variable. So return this, and then total salary equals employee calculate salary. That's it. And if we copy the calculate salary thing to the director, which we will do exactly that. So also we implement the same interface, salary interface, and we also need to specify that calculate salary method. And that is much more elegant. So every class that we need will specify that method, and it doesn't matter how it is actually implemented. Every class will take care of it internally. And then from our calculator, we will actually cut and paste it to here. We don't need total salary, we need return. So return employee, it's not employee, fixed month, which is public property, and then actually it can become private then if you want. This start date is a property, fillable property, and also a date in Eloquent, and then monthly percentage. Okay, and next, the final thing, we can delete everything here. So, and all of those methods. So this is the case where our salary calculator doesn't depend on the class of whether it's employee or director or shareholder or founder or CEO or whoever else. We just need to know that there should be a function calculate salary, and that rule is defined in interface. An interface calculate salary. This way, if we come back to definition of open-closed principle, if we add more employee type, we don't modify any of that class. We just extend the class with adding method to Eloquent model. And let's actually see how it works in practice. I refresh that page. Now I already have two directors placed. So we have two directors with their start date, and its total salary is 26,000. And that is exactly how it should work. If we return to our controller, we use the same function, the same library to calculate, but we specify different types of Eloquent models. Employees and directors are different, but it doesn't matter as long as the calculator still works and has the same interface. I hope that is clear with open-closed principle, and now let's move to the third principle with letter L. The third principle in our solid principle series stands for letter L, and it's Liskov substitution principle, named by the author Barbara Liskov. Now, it's pretty simple, one of the most simple out of 5. And it's mostly common sense, and you would probably need to do something nasty to violate that. So the principle says that derived classes should be substitutable for their base class. And again, it sounds confusing, I know, but let's imagine the example that you have a video tag class and you're trying to make a list of a lot of videos. And then from that video tag class, you need to specify YouTube tag class specifically for YouTube, and it extends the video class. So classical object-oriented programming, parent class video tag and child class YouTube tag, and then in the controller you're doing something like this. You're populating HTML. So you're getting the array of all those tags. So one is video tag, just general, another is YouTube tag, then you may add more tags and stuff like that. And you're rendering the video as it is, and in result you have this, you have HTML formed. So video tag plus iframe from YouTube. Now, what if you want to add another class called Vimeo tag, which logic has a little different logic. It also extends video tag, but not sure if you know, but Vimeo IDs of those clips of those videos are integers, are actually numbers. And what if we're trying to specify that video ID and check it whether it's integer. If it's not, then throw the exception. And that is exactly where we violate that substitutional principle, Liskov principle, in a way that we cannot substitute that class directly with everything. So if we do Vimeo tag and do some, I don't know, number, let's see if it throws an error, if it throws an exception. Refresh, yep, it does throw bad video ID, which is even bad error message because it doesn't say which. But the problem is that in those classes, those are, again, they extend the same video tag, but these classes accept string and this class accepts integer. So if we remove those brackets and if we refresh, probably the error will be gone. Yep. As you can see, player Vimeo is rendered really well. So this is the principle that says whatever class hierarchy you have, all the child classes should behave exactly like the parent classes, especially in PHP language, which is not that strict on types of parameters. So you can kind of interchange string and integer, but in this case you can't. And also, if you have any exceptions, for example, in Vimeo tag, if you have any exception, it should be handled in the other classes as well. So your child class shouldn't introduce any exception that doesn't belong to the parent class, to this one. Because what happens, for example, if a new developer comes to your team and want to introduce your own tag, I don't know what else, what video Wistia tag, for example, what he will do. He will look at the video tag at the general class, extend that, and he wouldn't even notice that there may be some kind of exception rendered in one of the child classes. So that is a good design principle to stick with the rules of parent class in all the children classes. It's kind of like an interface, similar, but also applied to object-oriented programming to parent and child classes. So that was Liskov substitution principle. I hope it's clear, and let's move on to the letter I of the 5 solid principles. In this lesson, we're discussing letter I in solid, which is interface segregation. And again, it's a fancy word, which actually means that none of the classes that uses the interface should implement the interface that it doesn't use. Also confusing, I know. Let's get to the example. And we take the example from our lesson on open-close principles. You can rewatch that. That's principle number 2. And basically we're calculating the salaries for directors and employees. Here's our dashboard, so employees and directors. And both of those are eloquent models. So employee and director, pretty similar, but with different fields and different logic. That's why it's different eloquent model, but they both implement salary interface. And we've defined that our salary interface has a function calculate salary, and all those models that use those interface implements that interface also has to implement the method calculate salary in whatever logic they want. Now, what if we want to add more methods to our interface? For example, we want to pay the salary, right? So calculate, and then we add a method, public function pay salary, which basically means that both director and employee should get the salary into their bank account. Now, we get PHP Storm notification violation. Class must be declared abstract or implement method pay salary. Basically, we're forcing to implement that function pay salary to implement pay salary method. No, that's good. That's good. So we don't have any logic for that, but I imagine it would be something like transfer or transaction, create in a database, blah, blah, something like that. So that's for our employee. But what if our directors don't want to take their salary? It's pretty common in business that employees get wages or salaries every month to their bank account, but directors or founders or CEOs, they just get minimum salary or even none or even no salary, and they earn their money via dividends or just reinvest into the business, so they don't pay themselves salary. But in our case, our interface forces us for the director to have that public function pay salary, which is empty, return null, because directors don't pay salaries. And that is a violation of that interface segregation principle. Interface segregation basically means that you have to have interface functions, only those that you're actually 100% sure that all of the classes will need. And so interface, by definition, in interface, there is another kind of violation or bad thing called fat interface. So interface should have like up to 3, 5 methods, maybe 10, but not too many, because too many methods in one interface, it actually violates another principle. Then it violates single responsibility principles, because probably by then with 10 or more methods your interface doesn't have single responsibility. So what to do in this case? We can introduce a separate interface, and every class, actually, not sure if you know, it can implement a few interfaces, one or more, comma separated. So what if we do another interface? So interface salary interface, and let's save it as payable interface. Payable interface. And then we open that payable interface and specify that it has pay salary. Payable interface, pay salary. So salary interface will only calculate the salary, and payable will be responsible for paying. And in our case, for employee, we will implement both salary interface and payable interface, which will give us pay salary method. And for director, we only need the salary interface, and we are not forced anymore to implement pay salary, and that will both work. So for director, there's only one interface, and for employee, there are two interfaces. There could be more. So this is the way how you separate the methods which are basically related to the particular interfaces, and you don't grow too fat with interfaces, because if you add more methods to the interface, then you are forced to implement them in all the classes, all the future classes, which may become troublesome. So that was interface segregation principle, letter I in the solid, and now let's move on to the last one, to the letter D. Finally, we get to the last letter D in our solid series, which stands for dependency inversion. And that is not the same as dependency injection, so don't mix those two. And this is quite a difficult principle to understand, but let's try to explain it. We return to our example of videos, YouTube, Vimeo, and video tags rendering from previous lesson. You can rewatch that, but here it is. So we render the videos, and we have a new class called video renderer, which basically accepts the video and does the rendering, calls the rendering from the actual class. So here is the rendering itself. And the problem with that code, it does work. So you pass 2 YouTube videos and you get the code, which is here. Refresh, so 2 iframe codes, HTML snippets, and that is fine. But we also have, in addition to YouTube tag, we have Vimeo tag, and we have video tag class, which is a parent of all of that. So that principal dependency inversion says that the renderer class, which is high-level module, well, the whole rule is high-level module should not depend on lower-level module. In other words, the more abstract class should not depend on concrete details of the implementation. In this case, it is violated, because our video renderer is more abstract thing. It should render anything that we pass. And YouTube tag is a concrete implementation of a YouTube specifically. So we need to change that YouTube tag class to video tag, which is higher level video tag, and then we can pass more videos like new Vimeo tag with some number and others. So In other words, in all the abstract classes or interfaces, we should pass the classes which are as abstract as possible and as high level as possible. With that, we probably should even add an interface here. So video tag is the parent class of all of those, but even here, maybe in the future, we have some more complex video tags with more, I don't know, with more structure. So even better way is to have an interface, video interface, which is even more abstract. So PHP namespace app interfaces class, no, it's not class, it's interface video interface, and it should have a function called render, and now in all of those classes in video tag and everywhere we should probably implement that video interface here. So in video tag, then in Vimeo tag, actually it shouldn't probably be specified, but let's try implement video interface, video tag, Vimeo tag, and YouTube tag. So here as well, implements video interface. And then in our renderer, we can specify video interface. That means that to the renderer, we specify any class, any object of any class that implements that video interface. So in the future, it will be much easier to create more classes like Wistia tag or any other video tag that would implement the higher level abstraction, which is interface. To recap, the dependency inversion principle says that the more higher level modules or abstractions should not depend on lower level modules or concrete implementation. It should depend on the abstractions, which is usually interface or high level classes. That's it with solid principles, 5 lessons. I hope it was useful. Not exactly Laravel specific, it's more about object oriented programming, but still discussing the structure of Laravel code, it's pretty useful to know.